what's up guys, Neat J here. Welcome to my video. Today, I'm going to show you some RNDR render network test. RNDR render network is distributed GPU rendering on the blockchain. We can use those GPUs on the blockchain. That is much faster, and we can use our own GPUs at the same time without waiting for the long time rendering. We just have to pay some credits to get this done. You can have a rough understanding of the cost by my case, and maybe waste less by my testing results. I'm going to use an X-particle included Cinema 4D project to do the test. The RNDR render network does not support X-particles directly. It should be baked as an alembic in theory. I'll do some tests, and besides the Octane render version, I'll also test the Redshift version. So, let's jump right in and explain each case in the test. Now we are in Cinema 4D. I want to test if the X-particle system can work without baking it to alembic. I've already cached this X-particle system. Now I'll export this file as ORBX. If you don't know what ORBX is, here's the info. ORBX is a container format that includes all animation, data, models, textures, etc. that is needed to transfer an Octane scene from one application to another. Let's go to the render settings. In the main tab of the Octane render settings, find the ORBX exporter. Check enabled and ignore rendering, set the ORBX file name, and hit start export. The picture viewer will run the frames quickly in black. Just ignore this. And when this is over, the ORBX file will be successfully exported. Now let's open Octane standalone to check the ORBX. Click on Render Target. Actually, I'm now doing wrong. I'm zooming out the camera view. You shouldn't do that. I just won't save this change. Normally, you can lock this view to check. And you can still change the render settings here on the right. And if you are in OCIO color space and open the standalone for the first time, there will be a pop-up showing up to set up the OCIO color. I've already done this before. Okay, that's it. This step is to check the ORBX to ensure it has no issues. I'll upload this file later. Now let's use another way of preparing the render file. First, we need to install the Render Network Cinema 4D Wizard plugin. I'll put the link in the description. We will use this to zip the project for uploading later. This method does not support the original XP system. If we pack this file directly and upload it to the RNDR network, the particles won't be rendered out. So we need to bake this XP system for RNDR rendering, and export the XP system directly to Alembic won't work. There are two ways to do this. One is to cache the X particles as Houdini format and use the Houdini to bake the cache file to Alembic. But of course, this is not for everyone. Not everyone has Houdini. I'll show you the other way, which is to generate thinking particles and bake them to Alembic. Let's get into it. Click on the XP emitter. In the emission tab, click Thinking Particles. Check Generate Thinking Particles. Create a TP geometry. Open up the TP settings. Link the particle group tag to the TP geometry and to the XP emitter thinking particles. Uncheck Enable Cache. Play the animation. Yeah, it worked. Export the TP geometry as an alembic. Don't forget to check Selection Only. Import the alembic file as a polygon object. Now we can delete the XP system. Check the render viewer. We cannot see any particles. Create an Octane scatter. Place the particle sphere under the scatter. Drag the alembic onto the scatter surface. Check the render viewer. Now we can see the particles. add a shader effector to the Octane scatter. In the shader parameters, uncheck Scale. In the Shading tab, change the channel to Color. We cannot drag the material in the Material Manager directly to the effector's material tag. This field is for the tag. We have to drag this material onto the object and then drag the tag onto this field. Since the particle sphere is shading the image by using an instance color node, now we need to link the particle color source to the scatter, which is already shaded by the shader effector. Change the material projection to flat. Still cannot see the color in the render viewer. Let me see what's wrong. Oh, I didn't link the shader effector to the scatter. Just drag the shader into the scatter's effectors area. Check the render viewer. It still doesn't show up, but we can see a very light color there. I know what's wrong. Go to the Parameter tab of the shader. Uncheck Use Alpha Strength. Check it again. Yeah, the color appears, but not the right projection. Let's go to the top view. Select the material tag, right-click the tag, and select Fit to Region. Drag a rectangle on the particle shape. Check the render viewer. Yeah, it worked. I'll change the instance color space to match my project color. Okay, the Alembic workflow is done. Let's open the Render Network Wizard plugin. Here is a checkbox called Create Backup Before Running. The first time I used the wizard, I checked this box. When I uploaded the zip file to the network, it could not be processed. And the reminder said, the file contains multiple projects, something like that. I won't check it here. I'll just check these two boxes and click on Check and Zip. The warning says, 2 materials found that do not match active render engine, just ignore it. That won't cause any problems here because those are standard materials. Okay, those are the 2 ways to pack projects for the render network. Let me show another example. That is the Redshift version of rebuilding the particles by using Matrix. Let's get into it. This is the Redshift version that I've already created. It's similar to the Octane scatter version. Just use the Matrix instead. Let's rebuild it now. Let's delete the Matrix and shader and rebuild it now. This is the thinking particle alembic object. Create a matrix. Place the particle sphere under the matrix. Change the mode of the matrix to object. And drag the thinking particle alembic object onto the object link. Change the distribution to vertex. Add a Redshift object tag to the matrix. In the Particles tab, change the mode to Custom Objects and drag the particle sphere in. Add a shader effector to the matrix. The same as the Octane scatter shader settings. Okay, now the particles are shaded. In Redshift, there is a specialized particle material called RS particle. We can see from the node editor that it uses the color user data, which automatically reads the shader of the matrix. We can customize our own particle materials in the node editor. Okay, that's it. And then we can use the wizard to zip the project. Now I have these 3 files already. Let's go to the RNDR render network. In the scenes viewport, just drag and drop all the files here to upload them. Okay, they are all uploaded now. Here's a reminder. Let's go check the guide. The guide lists all the supported C4D version and render engines and Redshift in beta. Actually, it doesn't mean that other versions of Cinema 4D or Octane or Redshift are completely incompatible. Maybe some new features like Cinema 4D, new soft body system, or new particle system will not be compatible. But if you don't use the incompatible features, maybe the other versions also can be used for network rendering. Actually, I've already used the Cinema 4D 2025 for the render network. They worked. Let's set up the ORBX file first. Click on Create New Job. Set the render settings. Set the outputs. Choose your project color space. If you have additional settings, just follow the step to set them all. Now we are in the network settings. There are two tiers to choose from. One is priority. It says increase priority for quickly accessing powerful distributed GPU nodes. And the other tier is economy, which is cheaper, but not as powerful and fast. I'll choose economy, and I'll set the minimum node VRAM to 3 GB. Here in Generate Estimate, this is for estimating rendering costs by entering the Octane bench score of your computer and the time it takes to render a single frame. It's just a rough estimate, not the exact price. Let's go on. Click Create Job. Now it's in render. We can go back to set up the other two zip files. After creating all these jobs, we can just leave them there rendering. Let's take a look at the frame progress. Here, we can see the progress of all the frames. When they are rendered out, we can review them to check the rendering results. And if a frame is taking too long and not rendered, we can request new node for it, but there will be an additional cost for the new node. Now, we can see that all the 3 jobs have some frames rendered out now. I'll go back when the first one is finished. Okay, now the Redshift version is finished. Here says 201 frames require review. Just click here to review all the frames. And we can click on the single frame to review it in full review mode. If there are no issues, click Select All Frames and click Accept Selection. Now let's download the render files. Here, I'm gonna use the Render Network Download Manager. You can download this tool from their website. I'll put the link in the description as well. Click on Copy Links to Clipboard and just paste it into the Download Manager. That's it. And the other 2 jobs are all the same process. Okay, now let's take a look at all these 3 jobs. The Octane versions, their render settings are the same, just different exporting format. The ORBX format cost 4.85 credits, and the network render time is 76 minutes. The zip format cost 4.15 credits, and the network render time is 92 minutes. The ORBX format is 20 minutes faster and costs a little more. I don't think it's a huge difference. Let's take a look at the exact same project using local rendering on my computer. We can see that the first frame was created at 7:22 p.m. and the last frame at 12:29. The total render time is about 307 minutes. So the network rendering is over 3 times faster. It depends on your render settings and scene files. And of course, the local rendering time depends on your device, your GPU. When we are in a hurry, we can even choose the priority tier, and we can split the file into different parts to render on the network at the same time. Now, let's take a look at the Redshift version. Its network render time is 27 minutes, and the local render time is about 47 minutes. Let me do one more test. I've set the denoiser pass of the Redshift version, and it's uploaded now. I'll test both priority and economy tiers of the same file. I'll speed up here. Oh, wait here. I just went to make a cup of coffee. The priority tier 1 has cost over 40 credits already. I'm gonna stop wasting my credits now. Click on Stop Job. And I'll select Stop in Progress Frames. Just cut it. Now we can see the time. Cancelled at 9:04 a.m. The process took 16 minutes. Let's just wait for the economy tier to finish. I'll speed this up. Okay, it's finished. It cost 3.22 credits, and the total render time is 19 minutes. It's much cheaper than the priority tier, and the render time is not longer. Let's do the math. The priority tier 1 cancelled at 69% progress and takes 16 minutes. And the most important part, it already costs 45.83 credits. That's too crazy. I just wasted 45.83 credits on a cancelled job. I think you can save it now. But of course, I think this will not be the same in all cases. Maybe it'll work in Octane engine, but for me, I don't want to test it now. I've always used the economy tier, and I'll still use economy tier in the future. Let's take a look at the new Redshift file, local render time. It's about 205 minutes, and the network render time is 19 minutes, costing 3.22 credits. It's 10 times faster, and the cost is very low. That's worth it. Okay, that's all for the RNDR render test. If it helps, feel free to like, comment, and subscribe. I'll see you in the next video.